Okay, 7.5, proportions in triangles. Well, we've been dealing with proportions in triangles already, yes? So we're just going to give you some more. So it says side splitter theorem. Okay, what do you think a side splitter is?
Cutting it.
It cuts it. It splits the side, yes? Okay, it says if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. So if it divides it proportionally, we can use proportions and ratios to solve it, yes? Which we've been doing for the last, well, maybe week and a half that we've been in school for 3 weeks, right? So my splitter is parallel to the bottom, yes? So that means this piece goes with this piece, and this piece goes with this piece, yes? Or this whole piece goes with this whole piece, just like we've been doing.
So is this like the one that you helped me with, but like
Kind of.
there's more to it.
Mm-hmm. Okay, so now it says triangle mid segment. What does mid mean?
The middle.
The middle. Okay? If a segment joins the midpoint of two sides of a triangle, then the segment is parallel to the third side and is half as long. So, looking at my picture, this GH cuts ED in half. How do I know it cuts it in half?
Wait, because there's a line.
There's a dash, right? That means those are congruent. How do I know that GH cuts EF in half?
There's two dashes.
There's two dashes. So since it cut both of them in half, then that means it is now what? Parallel to the bottom. So it's a way to know something's parallel and not, and then, so if I know it's parallel, can I apply the statement up above it then? Yes. Okay, so it says find X, Y, and Z. So here's X, here's Y, here's Z. Oh, here's X also.
So to find X, would you just put them equal to each other?
No. We got to use proportions, yes? Okay, so if I look at the X, if you want to start with X is down here, and I have this whole top part. So do you see there's 1, 2, 3, 4 triangles?
Oh, yeah.
Everyone see that?
I thought it was 3.
1, 2. What? There's 1. There's 2. 3. Okay, 3. I wanted 4. There's 3. Sorry. So there's 3 triangles. So I can start with X equals X plus 2. Now, X and X plus 2, are they both on that bottom segment?
Mm-hmm.
Yes? So I know that these two are parallel. So that means that X is corresponding with 12. And X plus 2 corresponds with 16. Everyone following?
Could you put X over X plus 2?
Mm-hmm. Okay, this X plus 2 is a quantity, so we probably should put parentheses around it, yes? So since we have numbers, I don't know how you want to do it. I personally, when I have an X on both sides, I'll multiply this side by 12 and this side by what? 16. So that gives me 16x
equals 12x plus 24.
12x plus 24. Because you did what, Tristan?
Distributed.
Distributed. Good job for doing that. So now do I have a basic algebra problem? So minus 12. So 4x equals 24. Divide by 4. So x equals 6.
If you were to do it the other way, can you do it the other way as well? Or is it just the same?
Well, if you had x over x plus 2, I would multiply over by x plus 2 and over by 16.
I simplified them first.
Okay. But
So
multiply
then-
over by what? You just have to do the same thing. You have to distribute. You have to multiply over.
So even if you move the x plus 2 over, you would still distribute the number.
You always have to. It's a quantity. That's why I said put parentheses around that x plus 2, because if you don't, you'll forget to distribute.
It's x equals 6.
Mm-hmm. Okay, so now we know x is 6. So this side is 6. And this side, well, 6 plus 2 is what? 8. Well, look at y. So above y on the left, I get 12. Below y on the left, I get what? What is this piece? No. 12. Above y on the right is 9. Below y is 9. So does that allow me to use my midpoint, my mid? So it says if that happens, then y is how much of PR? Half. So y equals 1/2 of PR. Just going to write it out so you can see it. So 1/2 of 30 is 15. I wrote a 3. Okay, so now we need z. How do you think we're going to find z, guys?
Well, z and 30
Say that again?
parallel.
Yeah, z and 30 are parallel.
So can you use 8 and 6 and 4 and 3? Why not?
Well, remember we try to use everything we're given? So what if I cover that up? Do I have enough information in those two triangles to find z?
Possible.
Okay, so if I look at z as the big triangle, yes?
Mm-hmm.
And y as the little triangle? I don't know, I put z equals. So if I have z, what do you want to put with z? You want to put 16 or you want to put 9? What do you want to put? Or not 9.
Would it be 16 and 12?
You're not putting both. You're putting one thing. Which side do you want? Left or right? 16? Okay. So what corresponds to z in the little triangle?
30.
What?
30.
30?
Oh, in the middle triangle?
Yep.
15.
15? Everyone follow? Okay. So 15. What corresponds to 16 in the little triangle? 12?
And then
So 4 and 3, right? Multiply by 15 and 5. And 4 times 5 is 20.
I use the big triangle.
That's fine. As long as you got 20. Okay, anyway I went, did I have to use something I found? Yeah.
What do you use? So we use z and y.
Mm-hmm. Because Z and Y are corresponding.
And then
And you picked 16.
12 because
You picked 16, so on that same side, 12.
because it's the long side.
No, it's on the left. It's just on the left. You use the left side of the big triangle, so you have to do the left side of the smaller triangle. These aren't right triangles.
So it doesn't matter what.
No, if you chose the left side, you stay on the left side. If you chose the right side, you would have stayed on the right side. Xander, you good? His eyes look really heavy. Okay, so either way I went, I had to use Y or I had to use X to find Z. So just make sure you're being careful with your math. Okay, last rule, I think. Corollary, that means since I know this, I can know this. To the side splitter theorem, we have this picture. What do you notice about this picture? Do we have a bunch of what? We have a bunch of parallel lines, yes? Okay. So if 3 parallel lines intersect 2 transversals, do we have 3 parallel lines?
Yep.
Do they hit 2 transversals?
Yep.
They all hit the same 2, yes? Okay. Then the segment intercepted on the transversals are proportional. I can't talk. Can't spell either, evidently. So if they're proportional, then I can use proportions and ratios to solve, yes? So that says that AB and DE and BC and EF. Could I also say AC equals, could I say AC and DF? And whatever you wanted to put over them. Understand? So we're just going to do the same thing, right? Okay. Ooh, we've got a pond. Look at that. Beautiful picture. A reflecting pool is separated by walkways parallel to Lincoln Street. So this picture, if you turn it this way, does it look exactly like the one in the theorem?
Yeah.
Yep. Okay. So all of these walkways are what? Parallel. So could you put some parallels on there? Yep. Okay, and Jefferson Street, which are parallel to each other. The city wants to add additional tiling around the pool. How much tiling does X and Y feet represent? So here's X, and here's Y. Hopefully, look on your paper, you'll see it better than up on my screen, won't you? Can't you? Okay, so should we go with X first? Okay. So Kerrigan, this might help you with setting up how I'm doing it. Okay, I personally would do X is equal to 60. Could I put X over 60 if I wanted to? Yes, Brianna, right.
Why is it equal to 60?
Because X and 60, like I have my fractions I'm going to set up, but I have X and 60 in my top. You could put X over 60 if you want. I like to put it sideways. So what corresponds to X?
24.
24. What corresponds to 60?
72.
72. So 5 and 6, right? For 12. 24 and 4. I got 20 feet for X. Did you? Okay. Now I want you guys to find Y. See if you can find Y. Okay, did you get 144 over 5? Almost. Oh, okay. Colton? No? What'd you do?
Not completely
Okay. Did you set it up the same way I did?
yeah.
I thought 55 was.
How did you set it up?
Y over 72 equals 24 over 60. I think I might have reduced wrong actually.
I was gonna say, I think you reduced wrong.
Don't hold me enough to
Because
say-
24 over 60 should be 2/5.
Yeah, I did 4/5 on it too.
Okay. Now, why on this one did I divide it out and do 28.8 feet?
Because it's feet.
Because it's feet, it's a measurement, right? And if they're asking for how much tile I need, if I tell them 144 over 5 feet of tile, they're going to be like, what? Right? So I have 20 plus 28, so I need 40, I'm going to say 49 feet of tile. Why did I say 49 feet of tile?
Because you rounded up since it's above.
Right, it's tile, right? I'm not going to go to the store and say I need
49
0.8 of a
plus
tile.
20.
How did you even get
Why do you have to add tile? Oh, because it's X.
Y- Yeah, because it says how much tile. What did you say?
How would they even give you 0.8 of a tile?
They don't.
They'd
How would they
measure it
that? Like, how would they measure that?
Probably.
in tenths. They give you 8 tenths, like, because 0.8 is 8 tenths, so they divide the tile into 10 pieces and give you 8 of them. Like, just with a ruler that had 10 markings. There's tape measures and marked in tenths. Okay, triangle bisector theorem. What is a bisector? Cuts things in what? Half. Okay, if a ray bisects an angle of a triangle, then it divides the opposite side into 2 segments such that the ratio between the segments is the same as the ratio between the sides adjacent. Okay, so what that means, if you look at your picture, see how do I know that ray VX bisects V?
Oh, those.
The 2 arcs, right? Okay, so it says that UX, right here, and UV, well, they put it up and down. So they put both of these, they have UX and WX right here. And UX corresponds to UV. And WX corresponds to WV. Now, I like to write mine as UX and UV. And so it'd be WX and VW. Now,
That's what they put.
You just switch to W and
Yeah.
what?
You did UX and UV, WX and VW.
Oh, wait.
Oh, I think
UX
you put
to...
UV under UX.
No, this should be... I had it right. I just wrote it horrible. And then I couldn't even read my writing. UV. Okay, UX, UV, and then WX and VW. So I can write it this way also. I meant to write it this way. I meant to do this.
Are your nails done? They look different.
Yes, I did. It's supposed to remind you of chocolates. Okay, so as long as I set them up good, I'm good. Got it? So, here's my example. It bisects, yes? I think this is a 16 down here. What do you guys think?
Yeah.
Okay. Oh. So x and 10, everyone follow?
Mhm.
X and 10. Well, I need this piece over here, yes? And the whole thing is 13. What is DC?
X minus 13.
How about 13 minus x?
Yeah.
So 13 minus x. And then 16. Once I set this up, am I doing the exact same problem I've done over and over and over and over again?
Yep.
So,
So 13 minus x and 16. So 16x equals,
what?
what's it equal?
16 minus x?
Nope, 16x equals what?
Negative 10x.
Negative 10.
Is that x is negative?
That'd be 130 minus
Oh, I'm
10x.
doing it different. I said
Okay.
it differently.
Okay. Minus 130 minus 10x.
Yeah.
And then that gives me 26x equals 130. And I divide by 26. And I don't know what goes into those, but I do know 2 goes in. Don't you know 2 goes in there?
Yeah.
Okay. So if I divide by 2, I get 65 over 13. And I bet 13 times 5 is 65, don't you?
Yep.
It is. So x is what? 5. Okay, I want you guys to see if you can set up this one on your own. Don't forget your parentheses. Or see if you can do it. I'll give you a minute and then I'll start.
Can you? Never mind.
Did you guys get x equaled 9? Why did you have to remember parentheses?
Because you had to distribute.
You had to distribute. If you notice, I multiplied over by 18, and I'm like, ooh, before I moved my 12, I'm like, 18 and 12 can reduce. Did that make my problem easier?
Mm-hmm.
Yeah. Rather than distributing 18, I don't want to do 18 times 7. How about you guys? No. Okay. So when you can reduce, take some time, reduce. Make your life easier. Questions? Concerns? Okay.
I
So
think redoing that whole